Hello and welcome back to IXL tutorials. This is Mr. Duffick, and today we are doing IXL P5, which is titled Similar Triangles and Indirect Measurements. So this IXL is very similar to most of the Ps that have you deal with similar shapes. The only difference here is they'll give you triangles that are similar, and they are going to be similar within each other. You're going to have a triangle that is made inside a larger triangle, kind of like this, by adding another side, which would be side NK right here. And so you're going to see that the smaller triangle is going to be similar to the larger triangle as a whole. Okay, so that means all the angles are going to be the same, which you see here, the 90 degrees. The angle for the small one and the large one right here is obviously going to be the same. And then K and L are going to be the same as well. And then that means also all of these sides are going to be proportionate. So that's the only difference. So we'll just do a few problems here and we will move on. Okay, so it says find T. So it says find the length of this side right here. Okay, no problem. So since we are dealing with sides, we are going to create our proportion ratios. Okay, and we see that side NK, or the T that we want, is clearly going to be similar to 6, or side LM. Okay, so we're going to make that one part of our proportion ratio, 6. And then we just have to compare it with another side that the triangles share. And it looks like we only have measurements for the one down here, so we'll do that real quick. So it looks like the base of our small triangle is going to be 4. Okay, so we'll do smaller over the larger. And then it looks like the base of the larger triangle is going to be 8, so we'll do over 8. Okay, small over large, side over base, right? Just be consistent. Doesn't matter how you lay it out. So now we'll do the cross multiplying. Okay, so we'll do 8 times t. It's just going to be 8t. And we're going to equal that to 6 times 4, which is 24. And then to get the t by itself, we're just going to divide both sides by 8. So we are left with t equals 24 over 8, which is 3. So t is going to equal 3. Okay, before I click that, I just want to point something out. Remember that since we know the triangles are going to be similar, that the sides have to be proportionate all the way around, meaning that the same scale factor is going to be applied between all the sides of the shapes, or just the shapes in general. For instance, you know that the base down here for the smaller one is 4 and the base for the larger one as a whole is 8. So how do you get from 4 to 8? What's our scale factor? It's just 2, right? 4 times 2 is 8, meaning the rest of the sides also have to increase by multiplying them by 2. So if 4 to 8 is 2 and t to 2 is going to be 6, what do we have to multiply by 2 to get to 6? That's going to just be 3, right? And that's how we got that here. So we just did the proportion ratio without having to write it out. If you can do that, that's totally fine. If not, please write out the proportion ratio. Okay? All right. So same deal here. This time we have a similarity statement, which is nice. And we see the triangles kind of share a corner right here, but same deal. Both triangles are going to be similar. Okay, so this one is just trying to find V. Okay. So what we'll do is we will set up another proportion ratio. Let's see, how do we want to do it? Well, let's set it up so we do the side over the side. So we'll do HI over, and it says HI, the second and third letters of the left side of the statements, is going to be similar to specifically IF or FI right there. So this side right here, so we'll just go FI over FI. Okay, and we want to figure out what the side IG is going to be. So we're going to do IG down here because, remember, we have to be consistent, right? If we're going to do the smaller over the larger, that means we have to do the smaller over the larger for that side as well. Okay, so what is similar to IG? Well, we'll go to our statements. IG or GI is the first and the second letter of the right side, so we'll go to the left side of the similarity statement here and see JI is going to be similar to GI. So we'll go to JI, which is right here, which is going to be 4 feet, but I'm just going to write JI there right now. Okay, so now let's plug in all the numbers. So we'll go HI is 3 over our FI, which is 6, which is going to equal JI, which is 4, and then IG is what we're missing, or we'll just write V because that's the variable they want to use there. Okay, now we'll cross multiply. So we'll do 3 times V equals 6 times 4, so 3V equals 24. And then to get V by itself, we'll divide both sides by 3. We'll go V equals 24 over 3 is going to be 8. So V equals 8. All right, 8. Good. Okay, so same type of problem here. We'll skip it. Okay, same problem here. We'll skip it. Looks like the same problem to me. We'll skip it. Okay, Shane found that a redwood tree that is 6 meters tall casts a shadow 8 meters long. Then Shane noticed a nearby maypole that is 12 meters tall. How long is the maypole's shadow? It says that Shane found a redwood tree that is 6 meters tall. So we'll just draw a straight line. We'll do 6 meters tall. And casts a shadow 8 meters long. So something like this. Well, actually, it's talking about shadow. When it says cast a shadow, it means the shadow is going to be on the ground, right? So it's going to be like this. Okay, it's going to be 8. Then Shane noticed a nearby maypole that is 12 meters long. How long is the maypole's shadow? So it's saying maybe like right here. Okay. All right. Well, you don't have to worry about that because I'll just make kind of a squiggly line to indicate this is the shadow we want. Okay, so it's asking what is the length of that one right there. Okay. Again, you can use proportion ratios or you can just do it in your head, but you know the tree is 6 feet tall and the pole is 12. So what is going to be our scale factor between the two sides or the two heights right there? Well, how do you get from 6 to 12? That's going to be 2, right? Scale factor of 2. So if we know the shadow is 8 of our tree of the 6th height, what's going to be the shadow of our 12th height? What's the scale factor? The scale factor is 2. So 8 times 2 is going to be 16. And that's all there is to it. Okay? Do 16. Okay. Another word problem right here. That's fine. You can just go ahead and do a diagram. 12 meters tall, 9 long, 4 meters tall. So same problem, just different numbers. Okay, same problem.